Today I have a special little treat. We have a friend who lives in Poland, a gentleman who is a fellow Mustang enthusiast who purchased a 1973 Mustang Grande from a dealer in Massachusetts. And it turns out this 1973 Grande has a 1985 5.0 liter 302 V8 installed, as well as an AOD 4-speed automatic transmission. So it is a radical departure from what the original engine and transmission would have been in this Mustang. And being that the newer engine is controlled by electronic computer as opposed to 1973 302 that had been in originally, you can only imagine what a nightmare it's going to be to work through the electrical ignition system using the wiring he has, the fuel system, and other components involved in this adaptation. This video is going to be dealing with how it is that we can take a neutral safety switch designed for the C4, C6, and FMX transmissions and adapt it through a special pigtail to plug into a neutral safety switch that goes into an AOD, AODE, and 4R70W automatic overdrive transmissions. And to do this, the objective is to take this connector for the AOD transmission and connect it properly to the older style neutral safety switch, where we can use the wiring from this to connect to this, so we can plug this into the existing main harness and have his backup lights work and his neutral safety switch work. Now, this is specifically for 70 to 73 C4 transmission, but a very similar, or the same actually, type of neutral safety switch comes on the C6 and FMX transmissions also. And even though it says on the package 70 to 73, there is something that is technically missing. 71 and 72 have 4 conductive leads and terminals. 1973 has another pair separate from this that is used to manage the seat belt interlock system, which nobody seems to have connected anymore. They didn't work very well, and so the federal government back in the early 70s said, okay, we give up, you guys disconnect it. And so no one uses that other pair of wires anyway. This doesn't have that pair of wires. It's no big deal. It's not a problem. So what I'm going to do is I'm going to cut this lead and strip the ends and attach the appropriate leads, if I can get this open, to the new plug pigtail that is made for the AOD transmission. Now this pigtail lead is marketed by Ron Francis. I got this from Summit Racing. I got a lot of these parts from Summit Racing. And I've used it on my own 73 Mach 1, which we installed an AOD transmission into about 3 years ago. And if you want to look up my YouTube channel under Gilbert Hale and do a search for AOD, you'll find out several different videos of the progress that we made with that project. One of those videos includes adding one of these into the circuit after cutting my C4 neutral safety switch harness. So this is basically a repeat, but maybe it's a little more information based upon a couple of the comments I got about what I put out there from before. Now, there's no need for me to have a lead that is about 4 feet long in total. But there's nothing wrong with it either, because I can always coil up the excess length. And I don't know on the car in Poland if someone has rerouted the other socket in the main harness this plugs into to move it out of the way when they put the AOD transmission in. I have no idea. So I want to give it as much length as I can, which won't hurt the thing. Unless I decide he says put in a C4 transmission, go back to this. I can tell anyone who's thinking about putting an AOD transmission into a first generation Mustang who wonders if it's worth it. In our case, it was definitely worth it. Our rear axle ratio, in the Mach 1 is 3.5 to 1. So we were turning just under 3,000 RPM at 60 miles an hour, which isn't horrible, but it was a little higher than I'm used to. Now that we have the AOD in there, I'm turning just under 2,000 RPM at 60 miles an hour on the highway. So the engine is working at a lower RPM. For anyone who is wanting better fuel economy, yes, that means better fuel economy. But for me, it was just a more relaxed environment. I wasn't wondering if the engine was going to grenade because it was turning such high RPMs at a fairly low speed. So all I'm doing now is I'm stripping back the wire tape that was put around the wires for the C4 neutral safety switch cabling. And the colors we have are basically red with light blue, another red with light blue, a black with pink stripe, another black with pink stripe. Now, in the case of the red with the light blue stripe, that is for the starter motor relay to allow it to crank over in park and neutral. Circuit number 32 and 32A, and it does not matter which way these wires are connected to their respective wires on the switch, because all it's doing is just closing a circuit or opening a circuit, nothing else. The black with purple can be hooked up to either of the two wires managing the backup lights, because all that's going to happen is one of these will have switch power on all the time, and the other will be sending this power to the backup light switch whenever the car is in reverse. So again, it doesn't matter which one goes where. So the first thing I'll do is I'll strip these wires. I'll start with the backup light circuit. and they're stripped. And then what I like to do is twist the wires. So I put them into the adapters that I have. They won't get all fouled up, and I'll have a wire hanging off to the side. Now what I'm going to use to connect these are heat shrink butt connectors. I have red, yellow, and blue, and the different colors correlate to different sizes of wire gauge. So I'll take 2 of these things out. Actually, I'll take 4 out because I'll need 4 all together. Put this away. And then for each of these, I will go ahead and, as I'm inserting the wire inside the metal connector inside, I twist it a little bit, I turn it. That way, I'm sure that it's going to go in nice and easy. Then I got these crimpers. There's a red dot, blue dot, yellow dot for the type of connector I'm going to be using. I line up on the part that is going to be connecting to the wire, and then I clamp it until it releases. Then I give it a tug, make sure it's solid. That is solid. Do the same thing for the other one. And again, I'll go down to this half of the metal inside the plastic housing. And squeeze and release and give it a tug. So those are ready. Now I'm going to do the other 2. I could have done all 4 at the same time. I just wanted to get a feel for it because, quite frankly, this is the first time I've used this particular product for the butt end connectors, and the kit came with the pliers. Normally I would do this a little bit differently, but I've seen other folks do some pretty cool stuff with higher quality tools. My old way of doing things would have worked fine, but I was curious about this, and so I decided to do it. So,
I think the connecting simpler too. You had a lot of issues with that other crimper.
yeah,
Crimping nicely.
I had issues with the other crimper. I had to use a couple different areas to crimp things down to get things to crimp as well as I wanted. This is a squeeze until I stop, release, a test. It's very, very simple. I can't say it's any faster, but if this results in a higher quality crimp, then I'm all for it. Okay, that part is done. Now my next trick is going to be getting my shrink wrap tubing, running down these wires, stripping these, and then on the sheath, the insulation of each of these wires, there's a description of what circuit it goes to. I have one that says backup lamp. Another one says ignition switch. Another one says start solenoid or starter relay. And the last one says backup feed. So the backup feed would go to the wire that is involved with the backup lights, either of these black and light purple striped wires. Either one will work. Because again, all that's happening is power goes in one and comes out the other. And when it comes out this, it travels through the wire that then leads to the backup lights and turns them on whenever the switch is in reverse detent position. Nothing fancy. So I'm going to excuse myself while I go find where I put my heat lamp tubes. I'll be back. Okay, so we've got our 4 butt connectors on the wires for the cable with the 4 terminals that will connect to the automobile socket for both the neutral safety switch and the backup light circuits. I'm now going to be preparing to connect this neutral safety switch pigtail for the automatic overdrive transmission into these wires. Now, I have used butt end connectors before, but never this brand of butt end connector with this real nice crimper. I always use a different brand that is not heat shrink plastic like these are. I would use these pliers to crimp. It works, but there was a little extra step or two. Now, for our own Mach 1, when I did the AOD neutral safety switch conversion, I used these low temperature solder heat shrink or heat shrunk connectors. I've had no problem with them. I also wrapped the 2 wires with connector in shrink wrap tubing. But there is a gentleman who has a very nice presence in YouTube. His name is Ken. His channel is called Wrenching with Kenny. This guy's about my age. He has a lot more experience than I do working on cars because I got involved in the early 70s like he did, but then I migrated to the computer industry and stayed there for about 35 years. He kept working on cars. He hates these low solder connectors, low temperature solder connectors. He has found that the solder doesn't flow correctly onto the wires and causes problems. Now, I've never had a problem with my connectors, at least not yet. He prefers to use metal connectors. What's inside these? Now me, I prefer to use something with a little bit of insulation on the outside with metal on the inside that makes a good crimp connection, and then use shrink wrap tube on top of it. It's like we would say in the computer industry is having belt and suspenders to hold our pants up. I'd like to make absolutely sure that I'm going to be providing a good connection and protect it the best I can from water, ice, whatever other material gets kicked up while driving down the road. So to help protect these circuits that I'm merging together with these butt end connectors, I have shrink wrap tubing, but it's a very special kind of shrink wrap tubing. If you take a look up here under specifications, it says 4:1 ratio, and a little bit further down it says, next one down, adhesive lined. So these things are made to work with marine or water presence applications. Good for boats. A marine grade application is going to be a superior type of product for shrink wrap tubing than what I would normally get for automotive use, which would be a 3:1 ratio in shrinkage and no adhesive on the inner lining. The importance of the adhesive on the inside is that when heat is applied, the adhesive material in there will melt and will, as this is tightening down on the wire and everything else, it will act to seal off water intrusion, prevent water intrusion. On top of these already being shrunk down, these are going to shrink down first, and then I'll have some of this over each end, and I'll shrink wrap those things down to make absolutely certain that I have a good watertight seal. So what I do to prepare is I select the size I want. It has to fit over these before they shrink. So this is the size I'm after.
So you put one or two of them on there, don't you need two?
I'm going to be using 2 per wire because these are not quite long enough
Okay, so you gotta slip two
to
before
get both
you...
ends as much as I want.
Okay.
So I'm going to use one at one end. I'll shrink it down with heat. And then I'll use another one at the other end, which will slide over this that has been shrunk down, and I'll shrink wrap this down so it is grabbing the wire, it's into the connection, and whatever is left over from this from the first time I shrink it down. So that's how I'm going to be doing this. I don't know what they do in Poland in winter as far as putting salt on the road to keep ice and snow from making driving in winter impossible. Using salt on the road for that purpose works, but it also causes body and frame metal to corrode very quickly. So I personally don't like salt on the roads. And for our Mustangs and our Shelbys, in wintertime when there's salt on the roads, I don't drive. Because I don't want to have those cars being destroyed by rust, not when I can avoid it. And it is avoidable, totally avoidable. Anyway, not knowing what is going on in Poland for winter driving, I want to do everything I can to protect these connections from having a problem because of water intrusion, salt intrusion, corrosion, other things like that. Okay, I have all 8 of the shrink wrap tubes down 2 per wire. And now that that's in place, I'm I'm going to go ahead and strip these wires and connect them to the appropriate associated wire for the circuit that I'm dealing with. And then see if I can find my heat shrink gun and get these things sealed up. Now there's all kinds of wire strippers on the market. Some are really fancy, where you put the wire into a hole, you squeeze, it clamps and strips the wire in one fell swoop. Or the one I have is pretty old school. I put the wire inside the appropriate size cutting hole, squeeze and pull, and it cuts and strips off the insulation down to where I did my initial squeeze. It's not fancy, but it does work. And then, like I did before, I twist the ends so all the strands stay together as I put them into the butt end connector that I'll be using to join this up with this correlating wire on the neutral safety switch harness side of the connection. Okay, I'll deal with the neutral safety switch first. So I have red that says starter solenoid. And this one says ignition crank. So these are the two that I'll be working with for the red and blue circuit for circuit number 32 and 32A. And it doesn't matter if I put these things in this way or this way, because again, all that's happening is the neutral safety switch is closing a connection that allows current to flow from one wire to the next. It doesn't matter in this application which wire has the hot and which one is being fed. Okay, so that one is in.
Hold all that.
So I put it down inside the red area for crimping, and crimp, and release. And then I pull, solid. Now I want to double check and make sure that this one is indeed switch crank for the ignition switch. And it is. I push it all the way in that I can. Go to my red dot saddle and my crimping tool. And tug. Solid. Now, these two wires, one says backup light feed, the other says backup light. And again, since all I'm doing is closing a circuit through the neutral safety switch, it doesn't really matter which of these black and purple stripe wires go to whichever of these two. It will work equally well. Nothing fancy about it. This one is in place. Get my red saddle down here. Line it up. Squeeze, release, and tug. When I tug, what I'm feeling for is any kind of movement at all. Now, I might get some movement of the metal conductive tube inside the plastic. That I might feel. So if I grab the two wires outside of this connector, I'll have a better feel for how solid that is, because here I feel that metal tube inside going back and forth. But when I pull these two wires away from each other, I feel no movement at all. Okay, I put in my last one. Line up the saddle. Now when I'm pushing this wire in, I crimp, release, and then, yeah, that's solid. They're all four really solid. So now what I'll do is I'll take the first four of these shrink wrap tubes and push them right on down. As far as I can. And now what I'll do is I'll see if Linda can go find either a hair drying gum, or better yet, if she can find my heat shrink tubing gum. Either one will work. When she comes back, we'll plug it in, and I have her record me wrapping this up. Oh, that sounds like it's a pun. Wasn't on purpose. Okay, we'll be back. Okay, so I have all four of these butt end connectors crimped onto their respective wires. And before I use my heat shrink tubing, I'm going to heat shrink these things down themselves. Now, I have read and heard that these are flame resistant, and I've seen some folks that use a small handheld torch or lighter, lightly touch this with the flame, everything shrinks up, nothing catches on fire, everything's fine. That's okay. If somebody wants to do it that way, I'm not going to stand in the way and say don't do it that way. Linda found the older heat gun that is made to do shrink wrap work. The one thing I like about this is that it gets really hot. What's missing is a special adapter at the end that is kind of curved, and so the hot air gets blown back on itself. So when I am working with shrink wrap items, it gives me heating on both sides equally. With this, I have to rotate this thing around. So Linda found my older heat gun. It's a nice unit, high and low fan speed and heat. It gets really hot, much hotter than a hair dryer. But this is missing a tip that is curved back, so that when I'm doing a heat shrinking, that curved tip will take hot air and redirect it back over the other side, so I can get heat on both sides of these items. Without it, I've got to work it back and forth. It works, but I would prefer if we've been able to find my newer unit that has the heat redirecting tip. That's okay, this will work. So high temperature, high speed. Give it a moment to warm up. Can you see the red? It's too far back. Okay. So I'm going to start with this. One is done. Two are done. A little more here. Three are done. Okay, they're done. I'm going to put this tip up so that it will cool off without touching anything, because that's really hot. And I can take a look at these and make sure that they are as sealed as I think they are. And they are. Now before I slide these shrink wrap tubes up over these connectors, I need to make sure these are cooled. Otherwise, as I'm pushing this down, these will warm up and start to shrink, and I don't want that to happen yet. Okay, those are pretty much room temperature, cooled off. Okay, I have them set up so that they are covering the entire end and the conduit underneath for each of them. So I will have plenty of this tubing to grip onto that end of the connectors, butt end connectors. So I'm going to heat them all up, get them to clamp down at the one end, and then one at a time I'll take them and heat them up at the other end to make sure they're nice and solid. So once again, high speed, let it warm up a little bit. And here comes the heat. So I'm going to check and make sure that they're all holding in place. And they are. You can see at the one end how they shrank down and they're wrapped around here, and the adhesive inside there is sealing so that water won't get in there.
You don't seal the other end?
I'm going to do the other end next, one at a time.
Okay.
I just want to get them fastened, anchored. Okay, I've inspected this one that I've done both ends, and it shrank down properly on the wire and on the butt end connector. I can see the sealant, the adhesive from inside the tube, because it's a little bit squeezed out at the end. So I see that one's done. So I'll do the other three the same way, and then when it cools off, I'm going to simply take the tubing, the other half, slide it over the previous tubing and shrink it down this end and this end. And that will do a good job of protecting this butt end connector from water intrusion or anything else that will cause it to corrode or have a problem. Probably will last longer than me. Okay, so while I'm doing it, you notice I'm holding the wire way away. I'm trying to not get that heat tip to hit me with hot air, because that really is hot. And I'm trying not to touch that tip with flesh because it's really hot. Okay. Those all shrank down really nice. I can see the adhesive between the tubing and the butt end connector. It's very clear looking. You see it here where it connects to the wire to the adhesive. So all that looks pretty good. There's a little worn, but I'll go and push these up here one at a time to get them in place. And here, I'm just going to hit it all at the same time. Take a look. Nice. If you look at this end here of the second heat shrink wrap, you'll see a little shiny spot just beyond the end. That's where the liquid adhesive has come out as it was clamping onto or attaching to the other piece of plastic shrink wrap tubing. but that's how I can tell I have adhesive, is that I have the shininess. So now, as far as I'm concerned, electrically, this is done. Now, I could have tested it before I did the shrink wrap tubing, but I guess I was either being too lazy to do that or confident that I got a good connection. So what I'm going to do is I'm going to show how we can test these things on the bench. I take the neutral safety switch and I plug it into its appropriate socket. And the way this works is that there is a switch position for reverse and one for backup, reverse, backup, and one for park and neutral. If I push the switch in part way, one pair of wires will end up connecting in here electrically. So I can test it a couple different ways. The way I'm going to do it is I'm going to get an ohm meter with alligator clips and connect one alligator clip to one terminal and one to the other. One male, one female. And then I'll engage the switch until I see the ohm meter show that it has a connection. There and only there. Then I'll switch alligator clips to the other two conductors, and I will do the same thing with the switch. I'll simulate going into reverse or park or neutral. And one position will close up the circuit, and you'll see that the resistance drops to 0. The other position, the other pair will do that. Once that is done, I'm going to try and make this look nice and pretty. Because I want to have whatever I send out to our friend in Poland to think that he's got a pretty good guy working on his car for him, with him, from the other side of the world. This is plastic wiring conduit. Out here in the United States, we can get this from many parts stores. This is only 1/4 inch inside diameter by 50 feet in length. So what I'm going to do is I'm going to put this entire strand of wire set inside a loom like that, so that all we're going to see is a black plastic loom and a little bit of the wires. I want to keep some of these wires exposed because if there's a problem and somebody has to troubleshoot this, I want them to have access to these wires without having to cut the loom open. And it won't hurt a thing to have a little bit of this exposed, because these things are in their own little weather resistant sockets as it is. So I'll get the ohm meter and my test leads, and then I'll do the test. All right, I have a volt ohm meter with a clamp ammeter. These things are great for working on cars and for a lower amperage type work. If you wanted to do something like measure how many amps are flowing through your starter cable going to your starter motor when you're cranking the engine, this isn't the unit you want. You want something that can handle higher amperage than this. I think this will handle up to like 15 amps of current before it overloads. Well, right now it's turned off, so there's a little on button, so I'll turn that on. And see if I can turn a light on this thing. There we go. OL is outside limit. Starting with a neutral safety switch, I'll connect one alligator lead into the female socket, another male lead to the other connector. And those two leads are for circuit 32, which is neutral safety switch. And then I will go ahead and press this button, which is what the transmission will do. And you just see it drop to 0. This is the position that switch will be in park or neutral. And that means that the current can flow from the one wire into the other. So from the ignition switch to starter relay. I move the alligator clip from the one socket conductor to the other socket, and the one male connector to the other one. Now right now it's OL. I go in part way where neutral and park would have worked, and we still have OL over limit, but I go in there. I had to get into the correct position for reverse, which is the plunger in most way, but not all the way necessarily. If I go in too far, it is going to go over the limit open circuit. So I let it out a little tiny bit, and now we have 0 ohms resistance. So this switch is working, and it's connecting things properly. Now I'm going to cross-check one of these testers on the neutral safety switch and one on the backup. This should stay open circuit
Over limit.
the whole time. And it looks like it stayed OL over limit for both those positions. So I'll try the other one. What I'm testing is making sure I don't have any bleed through between park and neutral and reverse backup lights. They have to be isolated circuits from one another. And nothing. So I am confident that when this unit shows up in Poland, all that Mr. Z needs to do is to install this new neutral safety switch into his AOD transmission. He has one now, but the photographs, it looks really beat up. A lot of road grit and grime on it. I want him to have a new switch because his little conductive pins are also all grimy. I want to have a good connection for him. So he has to install this, easy to do. Plug this in, this neutral safety switch. Find in his wiring for the Mustang the associating plug. He took a photograph of some wiring in his engine compartment, and I saw it looked like the backup light circuit wiring and the starter relay circuit wiring, and a plug that looked like this. So I think that's his matching plug that he has to get up to. And once he does that, if he has any excess wiring, he can coil it up and use zip ties to hold it. And he has all that extra length so that he can connect wherever he's got to connect to. Okay, so I'm going to go ahead and turn this off. These things, the better ones, after so many minutes of non-use, they turn off automatically to save the battery. And I'm sure that I've had that happen with this where I've forgotten to turn it off, and it turns off by itself. As a result, these batteries in here have lasted over 3 years. So I'm quite happy with this. I got this on Amazon. Let me take a close up so you can see what manufacturer it is, what model it is. And on the back there's a small label that may or may not be important. But this came with a couple different leads that plug into the bottom with a banana jack. So it can be used to measure voltage or ohms resistance, and this can be used to measure amperage flow of current. Very sensitive. I wanted it sensitive so I could check for parasitic voltage loss in batteries. This definitely does the trick. So anyway, nice unit. There's others like it, made by other folks, maybe made by the same folks, but Amazon, they got a bunch of those things. I think this is like 30 bucks when I bought it. Cheap at twice the price. Okay, I'm going to get this uncoiled so I can start making this look pretty. Once I have it ready to make it pretty, I'll get Linda to turn the video back on. Okay, I've got some wire or zip ties for wires. I've got my cabling, and I've got my conduit. Now this conduit is split lengthways the entire length of the tubing. And so the idea is to open up the one end enough to get the wires inside. And so now what I'm going to do is simply push the wire into the conduit and just work my way along. And as I work my way along, the plastic will come back down and kind of grip it loosely. It's not meant to be a tight grip. But before I go too far, at the one end, I don't want this coming apart on me when I'm further down the line. So I take one of these wire ties. I was going to use black electrical tape. I changed my mind simply because Linda found the wire ties first. And I put the wire tie around the end and I just pull it tight. And now what I'm going to do is take these special gardening shears and cut the end off pretty close to the locking tab. The reason I want it close is I don't want any of this around where it could poke someone in the eye. That would not be nice of me. I'm trying to be considerate of my future colleagues who are going to work on this car. I'll probably never meet them, especially being in Poland, but that doesn't mean I can't be nice about how I'm doing this.
Is that going to go over the connections?
This may not encapsulate these completely, so I'm going to bring it as far as I can and then pick it up. I could, if I want to, use some larger conduit to put over here and tie it all together, and I might do that, just make it look nice and pretty. This is supposed to be easy to do, to work it along, but this is being a bit of a challenge.
Too small.
It's probably because it's such a thin conduit that is harder to work with. Usually I use something bigger than a 1/4 inch. I use like 1/2 inch. But this looked like it would be good to use for this kind of wiring. So I'll probably use zip ties every once in a while just to hold everything together while I'm going. I just keep working it in, working it in. So then I'll hold that in place. I'll cut off those ends later. on working it. It'll eventually all come together and look pretty good. Looking pretty good so far. Okay. About time for another wire tie, just a few moments. Like so much of other work done on these cars, it's not hard to do the work, it's just tedious. And this is a case in point. Just a little bit tedious. Okay, we're getting down close to where the butt connectors are with the wire wrap that I've done. So I'm going to go ahead and cut this small conduit right here. And put this aside for the other half of the cabling. But look how nice that looks. Very clean. And I'll take this all the way up to here. And then I'm going to go ahead and do a zip tie here and here. I'll do the other part here. Now it's already wrapped in plastic tape. So this is maybe redundant, but I want it to look similar. I want it to have the conduit look. And when the other half is done, I'll get some larger conduit for this area, and we'll come back online with the camera and show what I've done to finish this up and section in a thicker piece to cover all this. And then I'll cut off the excess here of these zip ties and we'll call it done. Okay, we'll be back. Okay, I have all the conduit in place and secured by a bunch of little wire ties, and it looks pretty good if I say so myself. So I'm going to go ahead and use a bigger piece of conduit, larger, wider, to go around this piece, and I'll cinch it down here and all this will disappear. But what we will still have is some wire at each end of the harness. So if we have to do any testing, we can get to those wires.
Like my scissors, huh?
This is more than long enough, but I'm okay with having excess length. And this is how easy it is usually to work with these looms when they're heavier and thicker. They just go on real easy. So I'll go ahead and start in the middle and cinch it down and work my way out. Okay, cut these excess ends off. And I would say that this is ready to coil up and send off to Poland, along with the neutral safety switch. Okay, there you go, Mr. Z. Your sub harness all put together for you. This neutral safety switch is going to be threaded into a aluminum alloy case for the automatic overdrive transmission, AOD. And even though this is pipe threading and not supposed to leak once it's tightened in the case, I'm going to prepare this to help make sure it doesn't leak. I have something called Teflon tape, but this Teflon tape is kind of special. If you were to read the fine print on there, and I don't know if you're able to zoom in on that and read it or not, but this is impervious to gasoline. Not all Teflon tape is gasoline resistant. This is. Now, this won't be anywhere near gasoline, but it will be near oil, transmission fluid, which has solvents that sometimes similar solvents are in gasoline. So to make sure I don't have a problem, I'm using this gasoline resistant Teflon tape. Now, Teflon tape is not designed to prevent leaks. What it's designed to do is to lubricate the threads on piping thread. So, having said that, when the threads are properly lubricated, I find that there is less propensity for fluid leak to occur. So I'm not really doing this to keep it from leaking. It just happens to help. So I'll thread this on down. Doesn't take a lot. I'll snap it off. And then I'll just run the tape down into the shreds. A little extra there. And now, when I send this off to Mr. Z, he can take out the old neutral safety switch, put the new one in, and be confident that the threads will be lubricated with the Teflon tape, so he can get down nice and firm. We don't want to go too tight because it could crack the case. We don't want to do that. Very expensive mistake. But get it tight enough so that once the unit is in and there's oil under pressure or you're splashing up on this on the inside, it won't leak through the threads. We don't need oil leaks on that transmission. So that's what I wanted to show, is how to do the Teflon tape. And if you can find locally gasoline impervious Teflon tape, get it. Otherwise, you can get this on Amazon or other retail outlets that sell auto parts. The regular Teflon tape will probably do a fine job for a lot of applications, but for me, gasoline impervious is what I prefer to use.